Hello, um, class. Sorry I'm gone today. I have to present at the Rotary Club about some physics stuff that I'm working on. But anyways, today, here's the plan for today. What you're going to do is the very first thing that you're going to do is get ready for part 2 of the lab. And so part 2, you're going to work with partners that are your north-south partner. So north-south going this way in the classroom, okay? And you're going to partner up with them. If you don't have a partner going north-south, Coach Mack will group you up in a group of 3. But what you're going to do is you're going to do part 2. So before you do anything, it describes what's going to happen. Basically, what you're going to do is you're going to take ice, you're going to allow it to melt, and the question is, does the mass change? So first off, you should write a prediction, and don't just write, yes, the mass will change, or no, the mass will not change. Don't just say that. Make it more clear. Say, yes, it will change because blah, 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 blah. Or no, it will not change because blah, 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 blah. Okay? So be very specific in your prediction. Once you do that, one person you guys are going to go back in the lab, okay? And there's no need to be chaotic or anything like that. All the chemicals have been put up. You don't need to wear goggles, anything like that. It's a pretty simple lab in which you literally put ice in a beaker and put it on a balance and then just wait. So what you're going to do is you're going to go back in the lab. One person take their Chromebook in your group and one person don't. The one person that takes the Chromebook should type in the information that's needed for the data, like the mass of the beaker and the ice before, the mass of the beaker with the ice after, and the change in mass. The other person should grab a plastic beaker. It's right in the lab. You can't miss it, okay? Grab a plastic beaker or a glass one. It doesn't really matter as long as you're carrying it carefully. You're going to get ice out in the lunchroom. The ice machine's out there. And you're going to grab some ice from there. Now, when I go to the ice machine, I don't want to take my beaker and scoop up ice from the ice machine because odds are this beaker is somewhat contaminated. I don't want to be contaminating the rest of that ice. So instead of scooping into the ice, I'm going to grab the scoop to scoop the ice into the beaker. Now you don't need the beaker completely full, and it only needs to be about halfway to a quarter. That'd be fine. Once you have the ice, you take the ice back into the lab, put it on the balance, get the mass before, take it off the balance, and just let it sit. And make sure you know which one is yours because towards the end of class, you're going to come back and look at it. Okay? Now, everyone can use the digital balance because it shouldn't take that long to just have everyone use it. Now, please be patient and waiting. But once you have that, then you're going to come back to class. Once you're back in class, then we're going to start working on things that we started talking about yesterday. So I've kind of created this mock data here of the data table that you should have somewhat created. We talked about this a little bit yesterday. Beforehand, we know the mass of several things. I had these 2 graduated cylinders, one that was glass and one that was plastic. And the plastic one I used to go grab what we called liquid 1 or the sodium carbonate. And so I took my plastic graduated cylinder, and before I did anything, I had to stick that guy on the balance. And let's say it came up to be 10 grams, just making up numbers. So stick it on the balance, it gets a mass of 10 grams. Then what I would do is I would fill this guy up with liquid, and so I'm going to fill it up with water just so you guys can visually see the liquid in there. Okay, so I'll fill it up with a little bit of water. And so now it's got water in it. Everyone see that? Woo! It's got water in it. Or liquid 1, let's pretend it's the sodium carbonate solution. So I take this guy, and what I want to do with it is I'm just going to put it on the balance and get the mass. Well, then I'm going to do the exact same thing with the glass. So let's say the glass has a mass of 20 grams, okay, the glass graduated cylinder. And then I get the mass of that. I fill it up with some liquid. Again, I'll use water. This time it is the calcium nitrate. I'm filling it up with this water, which is actually, for our purposes, the calcium nitrate. I got it filled. Woo, there it is. Okay, so now I've got 2 of these guys, but before I mix them together, I got to get the mass of this after. Okay, so then if I just look at this data real quick, look at the plastic graduated cylinder up here with the sodium carbonate. If I have a mass of 10 grams all by itself, just a plastic graduated cylinder, and then I put the liquid in there and I get a mass of 12 grams, then the mass of the liquid is 2 grams. Pretty simple. Okay. The final thing I want to get the mass of is the mass of the beaker. Okay, and let's just say it's 100 grams. So then, what you need to know is we want to know the mass of everything that's there before and after. And so what we're going to end up doing is we're going to take this beaker, we're going to take this guy, pour it in there, take this guy, pour it in there, and then there should be a precipitate, but because I use water, it's no precipitate. So you have this beaker with the solid and this new liquid that formed. Well, you got to think about this. What was the system? And so the system that is the particles that I directly observed and measured. So when I stick this guy on here, what were the particles that I directly observed and measured? And then that's going to be the total system mass after. What I then need to do is go back to the beginning, before, and say, okay, well, what was there that is currently here? Because I want to track that. So I want to add up all the masses of everything that's being represented here beforehand, and then look at the change in mass from before to after. Okay? So here's what I want you to do with part 3. Part 3, I want you to draw first off, calculate this. Then on the board, I'm going to have a histogram set up. I want you guys to create that histogram. As a class, put your X in the correct bin. And then what I want you to do is create a particle diagram representing the change in mass. And so we talked a little bit about what particle diagrams look like with the mass change and everything like that with part 1. I want you to do the exact same thing with part 3, but base it off what you got for your data. Then what you're going to do is you're going to take a picture of that whiteboard, and you are going to post it on a brand new Google Doc. Okay, so not the Google Doc that we have. I want the lab C.1.2. I don't want it there. I want it on a separate Google Doc. And you're going to post that picture on there, and then you're going to write at least a paragraph explanation of why you drew the particle diagram that you did, explaining the change in mass, explaining what the particles represent, things like that. That's very key. So you're going to do that on a separate Google Doc. Then on Google Classroom, you'll notice that I posted an assignment for today. That is where you're going to post that Google Doc, and you're going to post that there. Okay, once you get all of that done, then what you're going to do is you're going to go back, grab your beaker. It may not be completely melted. That's fine. Put that on the graduated cylinder, or excuse me, put your beaker with the somewhat melted ice on the balance, get the final mass, calculate the change in mass, and then you're going to do the exact same thing. You're going to draw the particle diagram, take a picture, put it in that lab this time though. I don't need to have a separate Google Doc for that one. Put it in the lab this time, and we'll go from there.